Alright, let's look at the homework 7.4, problem number 5. Alright, so let's evaluate this integral using partial fractions. Alright, so partial fractions. So we have 5 over, quantity x minus 1 and the quantity x squared plus 4. Alright, so we can split it into a over x minus 1 plus bx plus c over x squared plus 4. Right? For this one, I'm going to go ahead and combine them together. So here we have put these guys together back again. So you have x squared plus 4, and then you're going to have to multiply a by x squared plus 4, right? And then we're going to have to multiply bx plus c by x minus 1. So we have a bx plus c by x minus 1. Right? So we just have to match these guys, right? So numerator here, and we'll have to match that with this guy right here. Right? So match those. Alright, so let's see. I'm going to maybe try some convenient numbers. Might be pretty simple. So we're gonna try. I'm gonna try. Let's see. I'm gonna try to find a. I'm gonna try x equals 1. Right. So if you do x equals 1, then this is gonna give us. Let's see. So 1 squared plus 4 is a 5a. Alright, then this is 0, so 5a is equal to, the other side is 5. So right away, we know that a is 1. So a is equal to 1, right? Then another convenient number would be, like 0 is always a good number. So I'm going to try x equals 0, right? So here, a is already 1, so you put that 0 here, so it's going to be 4 times 1, so it's going to be 4. And if you put 0 here, so bx is 0, so c times negative 1, so it's going to be minus c. And this is equal to 5. Right? So this means that the negative c, so I'm going to subtract 4. It's equal to positive 1. So we know that the c is negative 1. Right? So we already have c value and a value. So we just have to find the b value. Alright, then we can just try another nice number. We can try 2. We can try negative 1 or something like that. I'll try negative 1. So you have x equals negative 1. Right? If you plug in negative 1 here, we're going to get negative 1 squared is 1 plus 4, so it's a 5a, but the a is 1, so I'm going to just put 5. Right? Then c is negative 1, so it's going to be, so you put negative 1, so negative b minus 1, so it's going to be, let's see, I'm going to write that, negative b minus 1. And then you're going to multiply by negative 1 minus 1, negative 2. So it's going to be positive 2b plus 2. So this is equal to 5. Right? So we can cancel 5 and 5 on both sides. And it looks like this is going to give you, this is going to give you 2b is equal to negative 2. Right? So we know that the b is negative 1, right? Alright, so we got everything. So this is going to be equal to integral, right? A is 1, so it's going to be 1 over x minus 1, right? And the b is negative 1, so it's going to be, I'm going to put the negative x over x squared plus 4. And the c is also negative 1, so it's going to be negative 1 over x squared plus 4. I'm going to write 4 as 2 squared, right? And with respect to x, right? So antiderivative of 1 over x minus 1 would be a natural log of absolute value of x minus 1, right? Then second one, we have to tweak a little bit. So the derivative of x squared plus 4 is 2x. So I would like to have a 2 here. So I'm going to multiply by 2 and divide by 2. So what we get is negative 1/2 is a constant in front. Then you have a natural log of, we don't really need absolute value, so x squared plus 4, because that's always positive. Alright, and the last one, it's a negative sign, so this is going to be 1 over a squared plus a squared form. A is 2, so it's a 1 over a arctangent of x over a, and then plus some constant c. Alright, so let's type this in. Alright, so we have, let's see, natural log of absolute value of x minus 1, right? And a minus 1/2 natural log of x squared plus 4, right? And last one is minus 1/2 arctangent of x over 2 plus some constant c. Alright, so let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that it was clear.